So for introduction, first I'm going to explain about measuring CaCO3 in antacids using titration. Calcium carbonate in antacids react with hydrochloric acid. After the reaction, any leftover acid is measured using sodium hydroxide. This helps check the amount of CaCO3 in the product of quality control and accuracy. Second, what are antacids? Antacids are medicines used to treat indigestion and heartburn. Examples include brands like Gaviscon and Eno. Number third, different form of antacids. Antacids come in many forms such as tablet, liquid, powders, and capsules. Each form has different ways of being used. And number four, gravimetric analysis to measure CaCO3. Gravimetric analysis is a method where the amount of CaCO3 in an antacid is determined by measuring its mass after it's separated from the sample. This process ensures that antacids product contain the correct amount of active ingredient as stated on the label.
There are 7 steps in gravimetric analysis. Firstly, preliminary or also known as sample preparation. Secondly, precipitation of precipitate. Thirdly, digestion. Fourthly, filtration and washing. Fifthly, drying and ignition. Sixthly, weighing. And last but not least, calculation. Preliminary, or also known as the sample preparation, is a process to prepare the pharmaceutical sample in a form suitable for analysis. The pharmaceutical sample, such as tablet or solution, is dissolved in a suitable solvent to ensure that the API or the target component is in solution. In some cases, the sample may require preliminary treatment, such as filtering, heating, or acid-base digestion to eliminate interfering substances or to ensure complete dissolution. Precipitation of precipitate is a process that selectively precipitates the target component from the solution. A specific reagent is added to the solution that reacts with the target analyte to form an insoluble precipitate. The conditions, such as pH, temperature, and reagent concentration, are carefully controlled to ensure complete and selective precipitation of the target analyte, while minimizing the precipitation of impurities. Digestion is a process that improves particle size. Digestion helps small particles grow into larger ones, which are easier to filter. It also increases purity, where impurities that might be trapped in the precipitate are reduced, making the precipitate purer. And it also helps for easier filtration, for larger, denser particles to filter more easily and reduce the chances of losing any material. Filtration and washing is a process that separates the precipitate from the solution and removes impurities. The precipitate is separated by filtration using filter paper or filtration apparatus. The precipitate is washed with a suitable solvent, often distilled water, to remove any soluble impurities or excess reagent. These steps is crucial to ensure the purity of the precipitate, as any residual impurities could affect the mass measurement and the accuracy of the analysis. Drying and ignition process is to remove moisture or convert the precipitate into a stable form of whey. The precipitate is dried in an oven at a specific temperature to remove any moisture. In some cases, ignition, or also known as heating at high temperature in a furnace, is necessary to convert the precipitate to a stable anhydrous form. Weighing is a process that measures the mass of the dried or ignite precipitate accurately. The dried or ignite precipitate is cooled in a desiccator to prevent moisture absorption and then weighed using an analytical balance. Accurate weighing is critical as the mass of the precipitate is directly related to the quantity of the analyte. Calculation is a process to calculate the concentration or amount of the analyte in the pharmaceutical sample. The mass of the precipitate is used to calculate the quantity of the analyte based on the stoichiometry of precipitation reaction. The result is expressed in terms of the amount or concentration of the analyte in the pharmaceutical formulation. There are 3 things that you should consider while doing these processes. Firstly, selectivity. The reagent used should selectively precipitate the analyte without interfering with other components in the formulation. Secondly, purity and completeness. Ensuring the purity of the precipitate and complete precipitation of the analyte is essential for accurate results. Last but not least, accuracy and precision. Precise control of experimental conditions and accurate weighing are crucial for reliable results.
Now, we go to the part for determination of calcium carbonate in antacid. The objective is to determine the calcium carbonate contained in antacid by using gravimetric analysis. There are 4 procedures. Firstly, preparation of the sample. Second, precipitation of calcium ions. Third, filtration and washing. Lastly, conversion to calcium oxide. Here is the sample of the question. You can pause to read the question. First one is to calculate the mass of calcium carbonate in the sample. And the second question is to determine the percentage purity of calcium carbonate in the antacid sample. Next, we enter the calculation part. For question 1, we need to calculate the mass of calcium carbonate. The first thing we should do is list out the information given from the question. After that, by using the relationship between calcium carbonate and calcium oxide, you can get the mass of the calcium carbonate. Then the second question, which is, it asks for percentage of calcium carbonate. The formula to find percentage is mass of calcium carbonate divided with the mass of sample given times with 100. So, from the mass of calcium carbonate we calculated before, substitute in this formula and we will get the percentage of calcium carbonate contains in the antacid.
Lastly is the conclusion. The determination of calcium carbonate content in antacid tablets was successfully carried out using a wet titration method. This process involved reacting the antacid with an excess amount of hydrochloric acid, followed by titrating the unreacted HCl with sodium hydroxide. The results demonstrated that wet titration is an effective and accurate method for analyzing slightly soluble compounds like CaCO3. The measured CaCO3 content was consistent with the label claims of the antacid, confirming its effectiveness in neutralizing stomach acid. This supports the reliability of the product in managing gastric acidity. Additionally, the experiment highlighted the practical application of titration techniques in determining the composition and efficacy of over-the-counter medications. In summary, the experiment validated the acid neutralizing capacity of the antacid tablets and reinforced the importance of accurate quantitative analysis in pharmaceutical quality control.
This slide lists the reference we use to support our information. It includes key source articles, research studies to ensure accuracy.